And these help us limit our military casualties as highly trained men or pilots operate them from a control room. So, in a case scenario where a person would have to take a fighter jet and go destroy a target, you can, with the click of a button, send a UAV to do that, do the same task. Right. So, moving ahead, why have drones been in the news so much in recent years? Technological advancements have allowed drones and unmanned flying objects to be accurately guided over large distances. Better intelligence gathering on the ground can be done, which makes it possible to pinpoint and strike high value targets while keeping civilian casualties and other collateral damage as low as possible. Drones have also found their way in civil applications such as food delivery, agricultural surveys, and many more things. Right. So, talking about 10 days, uh, 10 years before today, uh, these technologies were still in use, but they were not as developed as these are today in today's times. Okay. So, at that time, drones were highly cost inefficient. They were highly uh, usually they had a very high cost of operation, and so the use was limited to only militaries and higher profile tasks. But these days we can find cheap drones which can perform well outperform the cost which are those are built in. And the just because of that, the cutting of the cost, these also have found their way in civil applications. Like these days there are trials being done in Dubai and other countries for people being carried on drones. Like you guys use Uber these days, there'll be Uber but in a form of a drone, so you'll be airlifted from one place to another. And various other applications like these, like medicinal deliveries, door-to-door medicinal deliveries, like medicines will be delivered to your home. So these kinds of civil applications are being researched upon. But apart from that, what we'll be learning about today is the military applications of these. So as the years have progressed, technological advancements have made the drones very and very much accurate. Like earlier down the years, the sensors which were being used, they had uh, a very low resolution or a very lower service ceiling, very low endurance. But these days, due to technological advancements, all these things are being polished and they're helping a lot. Like usual striking operation, which might have cost billions of dollars, can be done in a fraction of amount these days with the use of UAVs. Right. So moving forward, we'll be discussing about some design parameters which are taken care of while designing a drone, and we'll be specifically talking about fixed wing drones. So the very first one is aerodynamics, and this I'll let you know in brief what aerodynamics basically means. The other things which are I won't say parameters, but these are factors which you have to take in account while designing a drone, right? So some of these are payload. Payload is what payload are you going to drop on your drone, and endurance of the drone, which basically means how long is it going to fly. Speed and range of the drone, it's not mentioned, but we also take care of the service ceiling, like how high can your drone be able to serve you. Communication systems, navigation systems, and launch and recovery. Launch and recovery is a very important part of the drone design. Moving forward, the payload. Payload is the carrying capacity of an aircraft on launch. Examples of payload are warheads for missiles, space probes in a satellite. In layman language, if I try to explain you, anything that you put on your aircraft which you need to perform a task is called a payload. Let's say I designed a fixed wing UAV and it's supposed to take off from a place and drop some particular things on, let's say, a target A and then land on place B, right? So the things that are supposed to be dropped, which I'm going to load on my UAV, that will be a payload. Let's take a hypothetical scenario. You are a cinematographer, right? And you have to take cinematic shots of a place. So for that, you will need a camera on board. So in this case, the UAV is your drone and the payload is your camera, which you require to complete your task. Similarly, for missiles, there are warheads as payloads. See, right? So that missile that you see,
सॉरी टू इंटरप्ट यू इन बिटवीन दया बट थोड़ा बहुत हिंदी में भी बोलते हैं ताकि लोगों को ज्यादा अच्छे से समझ आए बिकॉज यू नो वी आर ऑल इंडियंस, तो सबको हिंदी समझ आती है यहाँ पे. थोड़ा बहुत हिंदी में ट्राई करते हैं एक्सप्लेन करने को इस चीज को.
ओके, ऑलराइट, हिंदी में भी कर लेते हैं, कोई दिक्कत नहीं है. तो पेलोड, सो आप बेसिकली मेरी बात समझ सकते होगे, ठीक है? तो पेलोड इज दैट जो आप अपने ड्रोन पे डाल के उड़ा रहे हो उसको. एरोडायनेमिक्स पे आते हैं, ठीक है? इट्स द मोस्ट इंपॉर्टेंट पार्ट ऑफ अ फिक्स्ड विंग यूएवी डिजाइन. एरोडायनेमिक्स से ही सब कुछ डिसाइड होने वाला है कि एंड्योरेंस, आपकी परफॉर्मेंस क्या रहेगी यूएवी की. एवरीथिंग इज बेस्ड ऑन एरोडायनेमिक्स. If your design is not aerodynamically stable, it will cost you very much to operate, right? So मतलब I'll not go into technical details. काफी चीजें होती है, there's drag, there's lift and everything, but I'll not explain you that much. But आप लोगों को बस इतना जानने का है कि a better aerodynamic design will make your vehicle more efficient. जितना अच्छा उसका aerodynamics रहेगा, it will consume less fuel, whatever fuel you are putting on it. पेट्रोल है and maybe it's working on solar, maybe बैटरी पे चल रहा है, maybe electric है. Whatever it is, अगर aerodynamics अच्छे होंगे, it will consume less of it, whatever fuel it's using. Okay, so and it also determines the lift characteristics of the vehicle, like it's written here. So what happens is like आप जैसे भी अपना airfoil and wing डिजाइन करोगे, कितनी स्पीड पे कितना हाई वेट वो कितनी अच्छे से लिफ्ट कर पाएगा, that will also depend on that. Coming to endurance, आप यूँ कह सकते हो कि endurance is a factor of aerodynamics. Everything which we will learn now, endurance and payload capacity, it's all factors of aerodynamics. जितना better aerodynamics, उतनी better आपकी आगे की characteristics. Like so, endurance is a time of flight for a UAV. If I put a battery in a UAV, अगले 30 मिनट्स तक मैं उसको फ्लाई कर सकता हूँ. So the endurance of that vehicle will be 30 minutes. मैंने 30 मिनट उसको उड़ाया, वो मेरे vehicle की endurance हो गई, right? So usually it's measured in units such as hours and minutes, like I told you. And moving forward, right? For close range surveillance system, we usually take 1 hour endurance. Close range surveillance system like आज की डेट में Delhi police and other police services also, they're using these in areas where they need surveillance. कुछ events होते हैं, right? तो वो इन चीजों का यूज कर रहे हैं. They fly drones over a crowded area and उस एरिया की पूरी सर्वेलेंस वो रखते हैं इन चीजों से. So इसमें ज्यादा endurance नहीं चाहिए होती है. 1 hour का इनका its endurance is more than enough. आप इसको फ्लाई करो, 1 hour तक अपना सर्वेलेंस करो, you bring it back, change the battery and fly it again. 5 मिनट लगते हैं बैटरी चेंज करने में, so it's not much needed. इससे ज्यादा endurance. For long range surveillance systems, आपको 24 plus hours की endurance भी needed पड़ सकती है. It's not a specific number, it's just a general number, right? So let's say that I have a base in my home and I want to, मैं अपने college की कुछ surveillance करना चाह रहा हूँ. So for that I'll need to send my drone to my college. It will take like around 1 hour or so, and उसको मेरे को वापस लाने का भी इंतजाम करना पड़ेगा. So I'll factor in that 1 hour also. फिर वहाँ पे जितना भी मेरा मिशन का टाइम रहेगा, that I'll take in account. So this is just a short range example. इससे लंबे भी हो सकते हैं long range surveillance systems. That's why we take 24 hour plus only. Right? The mass of the fuel to be carried is the function of required endurance. Right? It can be as low as 10% of the aircraft weight for a close range UAV and can rise up to 50% for long range. देखो नेचुरल सी बात है, जितना ज्यादा फ्यूल रहेगा उतना ज्यादा एयरक्राफ्ट का वेट रहेगा, राइट? एंड जितना ज्यादा वेट रहेगा उतना ज्यादा उसको लिफ्ट प्रोड्यूस करना पड़ेगा, थ्रस्ट प्रोड्यूस करना पड़ेगा, उतनी जल्दी आपका फ्यूल बर्न होगा. सो आप ये कह सकते हो कि जितना ज्यादा आप फ्यूल बढ़ाओगे आपकी एंड्योरेंस उतनी कम होती रहेगी. हम डायरेक्टली एंड्योरेंस बोलना भी ठीक नहीं होगा, आपकी एफिशिएंसी उतनी कम होगी. लाइक ऑब्वियसली अगर आप 1 kg एक्स्ट्रा फ्यूल डाल रहे हो तो दैट वो 1 kg एक्स्ट्रा जितना आप एक्स्ट्रा फ्लाई भी करोगे, बट द थिंग इज वो 1 kg एक्स्ट्रा फ्यूल जितनी जल्दी बर्न होगा, अगर आप उससे कम फ्यूल डालो तो जो बचा हुआ फ्यूल है वो उससे भी कम टाइम में बर्न होगा, राइट? सो हम यूजुअली फ्यूल को परसेंटेज ऑफ द एयरक्राफ्ट वेट पे लेते हैं. ब्लॉक वेट एक नाम टेक्निकल टर्म होती है जार्गन, राइट? सो ब्लॉक वेट इज द वेट ऑफ द व्हीकल विदाउट फ्यूल. सपोज मैंने एक यूएवी डिजाइन किया, उसमें फ्यूल कैपेसिटी इज 50 लीटर्स, राइट? अब वो 50 लीटर फ्यूल निकालने के बाद उस व्हीकल का जो वेट रहेगा दैट विल बी माय ब्लॉक वेट. अब उसमें मैं कितना फ्यूल डालूंगा, आई कैन टेक इन परसेंटेजेस ऑफ दैट वेट. लाइक 100 kg का अगर मेरा यूएवी है, आई कैन टेक 10% ऑफ दैट मींस 10 kg ऑफ फ्यूल आई कैन ऐड. मूविंग फॉरवर्ड, categories of systems based on vehicle types. तो 3 बेसिक कैटेगरीज आज की डेट में जो हम कैटेगराइज करते हैं. वन इज HAL, which is high altitude and long endurance. Altitude सबको पता होगा, it's the height. It's a technical term for height जो भी हम यूज करते हैं. It can be measured in meters and feet according to the standard units which you use, right? So HAL, as the name suggests, is high altitude, low endurance, long endurance. तो सर्विस सीलिंग काफी हाई रहती है, बहुत ज्यादा हाइट तक जा सकता है. The advantage इस चीज का ये होता है, it can be undetected by radars. छोटे व्हीकल्स को आप बहुत हाई ऑल्टीट्यूड्स में फ्लाई करो, इट्स वेरी मच डिफिकल्ट टू कैप्चर दोस ऑन रडार. स्टेल्थ बढ़ती है उन व्हीकल्स की, आप एनिमी टेरिटरी से बहुत इजीली क्रॉस भी कर सकते हो. दिस कैन बी डन ऑन 2 एक्सट्रीम स्पेक्ट्रम्स ओनली. या तो आप बहुत हाइट पे चले जाओ, आइदर यू फ्लाई सो लो दैट यू आर अंडर द रडार. सो हाई ऑल्टीट्यूड ड्रोन्स आर वेरी हेल्पफुल इन दैट. सेकंड कैटेगरी इज मीडियम ऑल्टीट्यूड एंड लॉन्ग एंड्योरेंस. एज द नेम सजेस्ट्स, अगेन इसकी सर्विस सीलिंग इतनी हाई नहीं होती है, बट इसकी मतलब मीडियम होती है, एंड एंड्योरेंस इसकी भी HAL जितनी ही होती है, थोड़ी सी कम कह सकते हो, बट स्टिल इट्स लॉन्ग इनफ. एंड द थर्ड वन इज TUAV, मीडियम रेंज एंड टैक्टिकल UAV. this is the most commonly used UAVs in commercial markets. Okay, medium range and tactical UAV. The range order is between 100 and 300 kilometers. This is ये बहुत ज़्यादा बता दिया मैंने आपको. बट जो आपको कमर्शियल मार्केट में रेडी टू फ्लाई कमर्शियल ड्रोन से मिलते हैं, इनकी सर्विस रेंज भी 3 to 4 किलोमीटर्स की होती है. एंड इन्हीं बेसिक डिजाइन पैरामीटर्स यही रहते हैं, बट विद यूज ऑफ बेटर इलेक्ट्रॉनिक्स एंड बेटर इक्विपमेंट्स आप उस रेंज को बड़े प्यार से इंक्रीज कर सकते हो. लाइक इसकी जैसे 100 and 300 के बीच में दे रखी है. These have a very long range. This can be inter-country, intercontinental as well. Thousands of kilometers they can serve you, right? Moving on. This is the Global Hawk. Okay, it's a hail category drone. As you can see, ये देखने में आपको बड़ा लग रहा होगा, but for size reference ये देखो. This is a technician servicing the drone. So there's no pilot in this. Of course, it's a UAV, unmanned aerial vehicle. Okay. And these are some technical terms which is given. Wingspan is from the left to the right of the wing. कितना distance है? 39.9 meter wingspan है. And इसकी maximum endurance, like कितना max ये fly कर सकता है for time 35 hours without refueling. इसकी service ceiling, which is the maximum altitude it can go to, is 19,800 meters. And it has a payload mass of 1.360 kilograms. अब 1.360 kilograms में कुछ भी डालो. Let's say if I want to use this particular vehicle to capture the satellite view of a country, तो मैं वो 1.360 kg में एक सिस्टम डिजाइन करके फिट कर दूंगा जो कि मेरा वो फोटो खींचने का काम करेगा. सो इट्स अप टू द इंजीनियर और डिजाइन्स द पेलोड. फॉर द व्हीकल दिस मच इज सेल्फ सफिशिएंट. मूविंग ऑन, वी हैव सम मोर ड्रोन्स. दिस इज अ प्रेडेटर बी. इट्स अ मेल कैटेगरी ड्रोन, मीडियम ऑल्टीट्यूड, लॉन्ग एंड्योरेंस, and it has a wingspan of 20 meters and a payload mass of 230 kilograms. Right? Moving on. This is DRDO Nishant. This is completely built in India by DRDO. DRDO is the Defense Research and Development Organization, right? It's a TUAV, tactical UAV drone, right? It has a wingspan of 6.57 meters and has a maximum endurance of 4 hours and 30 minutes. Now, this particular vehicle was designed to drop shipments, like military shipments, heavy shipments. So it has a very high payload capacity, 380 kg. It's the empty weight of the drone and it can carry as much as it. Moving on, we have the navigation system, right? It is necessary for knowing the position of the UAV. वैसा तो है नहीं आप UAV को हवा में छोड़ दोगे and it will do its task. At every time you have to monitor. आपको ध्यान देना पड़ेगा कि कहीं अपनी जगह से अलग तो नहीं जा रहा है, कुछ abnormality तो नहीं आ रही है, anomality तो नहीं आ रही है, and various other things like that. Just a minute. Yeah. Okay. So the current popular method of position fixing is navigation between points using GPS. आप अपने फोन में भी GPS यूज करते होगे, ग्लोबल पोजिशनिंग सिस्टम. इट्स बहुत ज़्यादा हाई टेक भी नहीं, यही बेसिकली यही सेम चीज़ यूज होती है. इट्स जस्ट दैट द सर्वर्स एंड सैटेलाइट्स फॉर दीज आर डिफरेंट एंड दे आर वेरी एडवांस्ड. और भी काफ़ी नेविगेशन सिस्टम यूज होती है. डेड रेकनिंग एक चीज़ होती है, व्हिच इज फ्रॉम वन टारगेट टू अनदर, आप स्ट्रेट फ्लाई करते हो. बट बेसिकली दिस GPS is being used to monitor the position of the drones these days. It gives continuous positional updates. Okay? At a ground station where someone is monitoring the performance of the UAV, the person has to know कि वो UAV at the current position, time, कौन सी position पे, right? Moving on. इसके बाद for non-autonomous operations. Non-autonomous operations is when a person from the ground station controls the drone by hand. Autonomous तो हो गया, आपने मिशन फीड किया, बटन प्रेस किया, उसके बाद आपको बस बैठ के मॉनिटर करना है. The drone will do itself everything. But there are operations where you have to manually do things. A deadlifting operation है, you have to lift something, airlift something. You have to very precisely control the drone to lift. If it's a person, then बहुत ज़्यादा precisely चाहिए होता है. So in this case, there are other means of navigation possible. Like I told you, direct reckoning, this radar tracking. If you don't want to use GPS or satellites, you can do this also. Like, right? You can do radar tracking. It's very detailed. If you want to learn about radar tracking, we'll provide you links for that as well in the chat box in a little while. But it's very interesting topic. Me being myself from avionics, it's a very interesting topic, right? And the other one is direct reckoning. It's also known as inertial navigation system. And I'll not go into detail, but it is basically you have to calculate the parameters of the drone time to time, and based on that only you have to somewhat approximate that what is the position of your drone right now. And that's pretty much it for non-autonomous. And moving on to the communications, the principal requirement is to provide a data link between the vehicle and the control station, right? अगर आप एक ड्रोन है, आपने उसको कहीं पे कुछ टास्क करने के लिए भेजा, it's not like कि आप उससे कुछ डेटा नहीं लोगे. Without data, it's of no use, right? you have to take data. Data can be in form of so many things. आपको positional updates चाहिए, speed updates चाहिए, endurance updates चाहिए. If you're doing something like some information collection procedure, आपको वो information को भी चाहिए होगा. आप aerial survey कर रहे हो, आपको aerial data real time में चाहिए. So that kind of things you can communicate with the drone. And there are two basic tasks which are followed in the communication protocol. One is uplink and one is downlink. CS is the command station. Uplink is from command station to the vehicle. Suppose मैं एक command station हूँ and I have a drone flying right above me. मैं यहाँ पे कुछ भी टक कीबोर्ड पे करूँगा and that command will basically be executed on my drone. So that command which I did here has to be sent to the drone. So it's done by uplink. Downlink is the exact opposite of it. It can be used for feedback, जो मैंने किया वो हुआ नहीं हुआ, and other various other things, positional updates as I told you. Basically, these two things are there in communications. Moving on. This is just a diagram to show you how command links and radio spectrums work. Like this is the unmanned aircraft. One can be a direct connection between the command station and the aircraft. One can be via satellites, right? Launch, recovery, and retrieval equipment. This is a very important task, important part of drones, okay, right? Because unlike your aircrafts, you can't, I mean, you can, but it's not advised to use a runway strip for these tasks. Because usually what happens is you have to launch it very quickly. These kinds of tasks, especially in military operations, you don't have much room to play around with, right? You have to launch it from a launching mechanism only, like remotely किसी area में से आपको launch करना पड़ जा सकता है बड़े आराम से. So these kinds of things are very much important. So the first one is launch equipment. It is required for those air vehicles which do not have a vertical flight capability. Vertical flight capability is like for your fixed wings, right? आपको एक run लेना पड़ता है so to produce a certain amount of lift, right? So if you don't want to take that, cover that distance in which you basically gain that speed to generate enough lift, वो उसको vertically take off करा सकते हो. But for that there is special kinds of hardware which has to be installed, or the design actually is completely different for those UAVs. Like आपका जो four propeller quadcopter होता है, which most of you know as a drone, it can vertically take off, and so for the aircraft which don't have a vertical takeoff capability, these require a launch equipment. Launch equipment is nothing much complex. It's just a ramp. आपने aircraft carriers पे भी देखा होगा. There's systems which pull the aircraft very fast and they fly. So इसी type के equipment होते हैं, just a small scale, right? Second is recovery equipment. It is required for the aircraft without landing capability. So it takes the form of a parachute, right? अगर आपको aircraft को वापस भी लेके आना है and you don't have the capability to land it. So what you do is you attach a parachute to it, it slows down and then it glides slowly towards the ground and has a soft landing. And not just a parachute, there are other types of recovery equipment as well. Like एक particular area के ऊपर net लगाई जाती है and उस net में directly आप अपने drone को fly करते हो. So it doesn't get damaged also, but वो net पे पकड़ा भी जाता है. Second is retrieval equipment. It is required for transporting the aircraft back to its launch site, right? I launched it from here and I landed it somewhere else. Now I have to take it back to my launch station to repair it and prepare it for the next mission. तो वहाँ से यहाँ तक लाने के लिए retrieval equipment use होता है. Moving on. This is a UAV launch vehicle. As you can see, ये drone है and this is a fixed wing drone. इसमें vertical takeoff capability नहीं है. So this is a small mechanism which is designed. इसको बड़ी प्रेशर से इससे लॉन्च किया जाता है and it basically gains the speed required to be airborne. And this is an example of the retrieval. Like इसमें maybe because you want more endurance, better aerodynamics, you don't install landing gears. So instead of that, what you do is you attach a parachute to it ताकि वो बहुत soft land कर पाए बिना wheels के. Moving on, the current generations of drone. Let's talk about it, right? The current generation of drones such as the MQ-1 Predator and MQ-9 Reaper, both of which I'll show you in the next slide. These are capable of flying reconnaissance missions as well as offensive missions from anywhere around the world, right? They have 300 pounds of payload which can deliver it at a click of button, right? So these kinds of drones which are being used in current generations have been able to be developed with very much technological advancements, right? And both of these are designed with various separate tasks in mind, right? They have a very, very high stealth capability and they can fly without being detected. And they have, of course, like it's written, a very high amount of payload. So it's just like you can deliver whatever you need to your cavalry without being detected by the enemy. And these are basically designed with such kinds of things in mind, right? Moving on, these are the photos of the MQ-9 Reaper and the MQ-1 Predator. This is the MQ-1 Predator. It's a very good design. And basically what you do is the payload is stored in the nose belly of the aircraft, nose here. So this has a symmetrical airfoil. Now, you might not know what symmetrical airfoil is, but you just have to know इतना ही जानना है कि having a symmetrical airfoil means आप उसको उल्टा भी fly कर सकते हैं, right? So ये basically उल्टा होकर अपना payload drop कर सकता है. And for the MQ-9 Reaper, ये देखने में छोटे लग रहे हैं, but ये छोटे हैं नहीं. These have a very wide wingspan. MQ-9 Reaper का for a fact is 43 meters का wingspan. So this helps in getting a greater glide characteristic. आप कम power देके भी बहुत लंबे time तक उड़ सकते हो. इसमें बस ये एक ही engine fan लगा हुआ है पीछे, बस. That's more than enough for it to fly for more than like 8-9 hours. Right? Future of the UAVs. Let's talk about it. Anyone of you have any doubts till now, or anyone if you have any takes which you want to share with us?
Guys, you can write in the chat box if you have any doubts. There you can continue. I will read out the doubts if there will be any.
All right, moving on. Future of the UAVs, right? Let's separate the military applications and civil applications right now. Okay. For military applications, police monitoring and crowd traffic, these are things of the old times now. These are actually being used right now. And firefighting operations, these are still in research. And for military applications also, these are being researched. But what I'm more interested in the future of UAVs is its civil applications, because as beautiful pieces of technology as they are, they were designed for tasks like military operations, but nowadays they have found their way into civil market. Like people are using their drones for cinematography, and now researches are being done to provide them to companies to deliver airdrop shipments. Right? So as I see it, the future of UAVs is like anything that is being delivered that's requiring human efforts right now will be automated via UAVs. Like if you order anything from Amazon, it will be airlifted to you via a drone. And this, of course, needs a lot of research and a lot of work right now. It's already under the process, and this is being implemented. And for that, there is a separate type of design requirement. We don't need fixed wing for that. If you want to drop a shipment at someone's house, you'll obviously need a quadcopter because you have to hover at a single place to properly drop it or properly give it to them. So that's pretty much it about the future of UAVs. If you have anything to share, you guys can by opening your mic if you want to. Otherwise, that's going to be all from our side.
Well, I can see appreciation in the chat box. Guys, you can put on any doubts. Or if you have no doubts, I will be putting the quiz in here. So basically what you have to do is attempt this quiz. It is a rapid fire round quiz. We will be getting the results, and the top three participants will get a certificate in their mail. So I have sent the link in the chat box.
Guys, the quiz will be starting at 9:40. I hope you all have joined via the link. Please join. It's you can attend and please use your real names. You'll get the certificates based on that only. We're starting the quiz now.
Good evening, guys. Thank you so much for joining us for the quiz. I believe there was some technical issue. So I was saying good evening, guys. Thank you so much for joining us for the webinar and for the quiz. Uh, we hope you all enjoyed the session and it was informative for you all. Uh, we are still available for you anytime if you have any questions regarding the webinar and the quiz, and we'll be happy to help you at any times. You can drop in on our website and type any or all questions you have, and we will answer it as soon as possible. And this is to inform that we are having our next webinar tomorrow at 8 p.m. and it is on the topic 3D printing. Its registration will begin on our website at 10 p.m. tonight. So please spread the word, and you can join the webinar if you want to learn more about 3D printing and its applications and its uses in daily life and in commercial purposes as well. It is a very important webinar and the one of the most informative ones as well. So we'll really appreciate if you could join us in that as well. Once again, thank you so much for joining us tonight and have a good night. Goodbye. Thank you.